Good afternoon, ladies and gentlemen, and welcome to this panel session about improving the longevity of current mines through modernisation. My name is Fatheela Brovko, and I'm an Impact Area Manager with the Mining Cluster, and today I'll be your host. The aim of the Mining Cluster is to integrate with relevant CSIR capabilities, as well as partner with industry and government to support the growth and revitalisation of the mining industry. We hope to do this by innovating or creating innovative new processes and technologies aimed at improving safety, health and the environment, as well as improving the socio-economic conditions of mining communities and the mining industry, and then developing relevant capabilities to support the sustainable and economic growth of the industry. So South Africa has an exceptional mineral wealth that has enabled its industrial and economic development in the 19th and 20th century. So this mineral wealth continues to play a major role in South Africa's future development goals through mining. The mining industry, however, faces many challenges that would threaten the sustainability and growth. From a cost perspective, the mining industry is facing above inflation increases for most of the major inputs into the mining processes. Electricity and diesel are amongst the highest cost increases. From a safety perspective, we see that even though the fatalities and the safety statistics have improved over the past few years, there's still continuing journey towards zero harm. The mining industry also faces environmental and social challenges, such as post-mining landscapes, acid mine drainage, water prioritization, as well as the socio-economic conditions of communities around the mines. From a productivity perspective, we find that many conventional mines are showing declined productivity, be it from increased distance to the shaft, other logistical challenges, or just time spent at the mine face. A 2015 study by the Minerals Council South Africa resulted in a model that forecasts platinum and gold tons mined per year. The model predicted that the payable reserve mined conventionally will be depleted by 2025. The model also shows that through the implementation of modernisation, be it from increased efficiencies, mechanisation, or continuous mining methods, mining operations could be extended beyond 2040. This reinforces the need to modernise. So modernisation, or Mining 4.0, involves the heightened use of technologies and changes to processes and people. And this panel will focus on the research conducted by the CSIR's Mining Cluster in collaboration with academic institutions and other clusters facilitated by the Mandela Mining Precinct towards modernising existing conventional narrow reef underground operations in South Africa. Today, I'm joined by a panel of experts that are currently working on addressing the mining challenges in our industry. I would like to introduce Martin Pretorius. Martin is a program manager at the Mandela Mining Precinct, responsible for introducing innovation-related projects and managing these research project outcomes. Martin holds a BTech degree in mining engineering at the University of Johannesburg and has worked at platinum and gold on multiple projects at various depths. Martin also worked in various high-level multidisciplinary positions in mining, from operational, technical, project studies and strategic planning. Welcome, Martin.
Thank you, Fatheela.
Next, I would like to introduce Thobile Ntleko. Thobile is a senior researcher at the CSIR and is involved in mining-related projects that are aimed at improving the sustainability and profitability of the mining industry. Thobile holds a BSc Mining Engineering degree from the University of Witwatersrand, a Chamber of Mines Rock Engineering ticket, and is currently in a final year of completing an MSc degree in Mineral Economics. Thobile also has 8 years of underground hard rock mining experience, where she spent 3 years heading a rock engineering department. Welcome, Thobile. Finally, I would like to introduce Peter Klein. So Peter is a senior researcher at the CSIR's Energy Centre. Peter is currently leading the development of a thermal systems laboratory at the Energy Centre. Peter holds a PhD in mechanical engineering from the University of Witwatersrand and has 10 years of experience in finite element modeling and experimental analysis of high temperature thermal energy storage systems. Welcome, Peter.
Thank you, Fatheela.
So, Martin, could you please tell me how the Mandela Mining Precinct is addressing the mining challenges in a collaborative way?
The Mandela Mining Precinct was launched in September 2018, and it is a public-private partnership aimed at addressing the challenges the mining is facing, focusing on gold and platinum as a start. It was established as an outcome of the Mining Pakisa intervention, which is co-funded and supported by the Department of Science and Innovation, as well as the Minerals Council South Africa. The precinct is co-chaired by the Department of Science and Innovation, as well as the Minerals Council South Africa, and it is incubated within the CSIR. It is state representation by the Department of Minerals Resource and Energy, the Department of Science and Innovation, the Department of Trade and Industry, National Treasury, as well as the Department of Planning, Monitoring and Evaluation. In addition to the CSIR, the 3 mining universities are collaboratively partaking into the research projects. That is University of Johannesburg, University of Pretoria, as well as University of Witwatersrand. And it serves as a research spoke. It further includes engagement with organised labour, who provides ongoing participation. The SAMERI strategy stands for the South African Mining Extraction Strategy for Development and Innovation. The objectives of the strategy are twofold. First, the development technology solutions that will increase the safety and productivity, reduce the costs, and ultimately extend the life of mines for the betterment of the local community associated with the mining, as well as the country as a whole. Second, and equally critical, is to revitalize the mining research, development and innovation capability and capacity in the country, so that South Africa can again be seen as a focal point for many mining R&D projects. The SAMERI program has 3 main programs. The Mine of Today is covered by the longevity of current mine program, looking into current conventional mining practices, to investigate opportunities for optimization, to introduce modernized solutions in making mining economic viable, and to mine for longer, in this optimizing to prevent the mine closures and retrenchments. The Mine of Tomorrow is the focus point of the Mechanized Drill and Blast program. It looks at the equipment, the infrastructure and the technical designs of support to optimize the level of optimized mining, mechanized mining. The Mine of the Future is the center point of the non-explosive rock breaking program. It looks at the new rock breaking technologies to apply 24/7 non-stop operations and to extract the reef and only the reef. SAMERI has also 3 cross-cutting areas. It is advanced ore body knowledge. It's to understand the ore body and intend to look ahead of the face about approximately 30 meters. The real-time information management system is managing the flow of information as well as focusing on the 4IR for mining. So the successful application of technology central around people is a link between the people and technology, and it's developing the interface framework of the interlinkage process. The longevity of current mines is to modernize and introduce new solutions to current gold and platinum mines with best practices, methods and procedure outcomes. The journey map has been developed to list all production activities related to the production cycle, to investigate opportunities for improvements, and that led to the development of optimization tools to improve the efficiencies and also to develop alternative technologies like prototypes through the research and development interventions, to roll out as trials for the industry. Also, the blueprint models has been created to determine the most viable solutions to the extraction process. Some of the 2018-19 projects completed are the Stope Environment Project, which looked at effective cooling systems where people is exposed at high temperatures. Also, the project Shift Cycle investigated the interaction and impact of the shift cycle towards the production times, as well as the travelling time with the impact of the employee fatigue levels. The energy project investigated alternative energy sourcing, and the project drilling was also looking at the hydropower technology, optimizing those processes through developing prototypes based on industry criteria.
Thank you, Martin. So Thobile, the CSIR mining cluster led most of the projects under Martin's portfolio last year, and you were the lead for the Dingo Drill challenge that was successfully launched sometime last year. Could you please tell us about the challenge and what it entailed?
Thank you, Fatheela. So previous research indicated that the drilling activity is the most constrained activity in the mining cycle, particularly in hard rock mining. The current technology that is used is heavy, difficult to maneuver, difficult to ensure parallelism, and a whole list of disadvantages that make it difficult to acquire proper efficiency and productivity rates. It therefore became essential to develop a safer, lighter, and quicker drill machine to address some of these constraints. This is how the Dingo Drill challenge came about. So the industry was approached in order to get a consolidated list of criteria that address some of those constraints. Using those criteria, an open innovation challenge was addressed to the public where concept designs were required from the public. They were invited to actually submit these concept designs within 30 days, and these would be judged based on the criteria that was developed. At the end of the 30 days, a panel of experts then sat down and decided on who would be the challenge winners. After those were selected, contracts were signed, and within the contracts being signed, 120 days later, the fully functional prototypes were developed. These were launched in November, and then the surface testing also occurred at the Mandela Mining Precinct of those prototypes that were launched. So the timelines of the innovation challenge all occurred within the space of 1 year.
Thank you. So how does the implementation of the Dingo Drill benefit the mining industry?
So currently you would have a mine that decides that they require a particular technology. They would then approach a particular manufacturer and look at their suite of equipment, and based on that suite of equipment, select one that they feel that is most suitable for their mine. But that may not be it may not necessarily conduct all their needs. So with this innovation challenge, the drill was developed from the start based on consolidated criteria that come from industry, meaning that you have a product that addresses all the constraints that the mining industry currently faces. Secondly, current technology underground uses a highly inefficient power source, which is compressed air. As we go deeper, as the mines expand further from the shaft infrastructure, this compressed air becomes even increasingly more inefficient. So one of the criteria of this drill was for them to actually use a different power source to compressed air. And both of the challenge winners used hydropower as a power source.
Thank you. So the Dingo Drill challenge then addressed the constraints associated with the drilling activity in the mining cycle. Did you apply this learning to any other projects?
Yes, so when you look at the Dingo Drill, it may seem beneficial at face value, but what does it do to the overall financial standing of the business? This is why we have the blueprints. The blueprints are a financial evaluation model that uses inputs such as costs, your productivity, your production from a particular technology, and to get outputs such as your NPV and your IRR to see what that technology does. So for Dingo performance parameters, those would be input into the model to actually see that, yes, the technology is good, but does it deteriorate or does it improve the financial standing of the business? This would then be applied with our other projects that we've used, such as blasting, support, and anything else that we use within the mining cycle.
Thank you. So finally, Thobile, what other contributions is the mining cluster making towards the challenges experienced by the mining industry?
So the mining cluster is busy with other projects, such as safety-related projects with the Mine Health and Safety Council. One of these projects is a project for preconditioning to develop a tool that will assist mines to look at their rock conditions, to look at the seismically active structures, and then help them to decide on which best preconditioning design would be suitable for them in order to try and decrease the stress conditions and seismic risk. Another project we were busy with is with the Mine Qualifications Authority, where we look at a future mine. We are saying that mines will be mechanized, mines we are including 4IR. What is the skill set that will be required to make those mines efficient? And that was the investigation that was done with the MQA.
Thank you. Thank you. So Peter, we understand that energy is a topical point because of the constraints that it represents to the mining industry. And I'm happy to see that the mining cluster is also collaborating with the Energy Centre and industry. So we all understand that mines are price takers from an energy market and are facing increasing pressures regarding the rising energy prices and loss of production due to load shedding. You were involved in identifying alternative energy sources from Martin's program. So please tell me more about the role of renewable energy technology and how it can support our mining operations.
Thank you, Fatheela. Currently, electricity is really the primary energy carrier in the mining sector, accounting for more than half of final energy consumption. So a lot of mining operations were really developed in a context of very low electricity prices, and the rapidly rising electricity prices over the last 12 years or so have been very difficult for the industry to absorb. In this context of rising grid prices for electricity, the costs of renewables such as solar PV and wind have really been decreasing quite rapidly. And this is now presenting new opportunities for mines to look at embedded generation technologies. Currently, it's cost prohibitive really for a mine to go completely off-grid. So an optimal solution will really be a mix of grid electricity and embedded generation. So embedded generation is really a new opportunity for mines to reduce their energy costs, reduce their carbon footprints, and also add to their energy security.
So Peter, please tell me more about the role that embedded generation on mines can play in terms of alleviating load shedding constraints.
Despite COVID-19, 2020 has really been one of the worst years of load shedding to date, with more than 1.3 terawatt hours of energy that has been shed from the grid. The National Integrated Resource Plan, the latest version, IRP 2019, has identified that there will be a short-term capacity gap really ranging up to about 2023. They estimate that to be in the order of 2,000 megawatts. The CSIR Energy Centre, some of my colleagues recently published some work titled Setting Up for the 2020s. And they put forward really a three-pronged approach that could be adopted to close this capacity gap and avoid load shedding. The first area is a customer response at scale through embedded generation. The second is the rapid rollout of the risk mitigation power procurement program from the DMRE. And the third is the implementation of the IRP 2019. So in terms of embedded generation, there's an allocation in the current IRP of 500 megawatts per year from 2023 onwards, as well as an undefined allocation to avoid this capacity shortage in the short term up to 2023. In some of the CSIR modeling, what they've been putting forward is really increasing the embedded generation levels up to the order of 4.9 gigawatts by 2023. When looking at mines, many mines have already done a lot of project development work for their own on-site embedded generation, primarily through large solar PV plants. And many of those projects could be rolled out in a rapid manner which would alleviate some of the pressure on the national grid.
Thank you. So how would mines deal with the variability associated with solar, PV and wind?
There's really 4 key approaches that can be used to handle this variability. These include demand-side management, energy storage, flexible generation through either CSP, biomass or gas, as well as a new emerging concept around sector coupling. As you can see on this slide, given the rapidly reducing costs of renewables such as solar PV and wind, it's envisaged that electricity will really become the primary energy carrier of the future. So sector coupling is looking at linking the power sector to other end uses of energy within the economy. So this is primarily transportation as well as thermal energy in the form of heating and cooling. This can either be done directly, for example, in transport, we're talking about electric vehicles or electrification of heating loads, or it can be done through an intermediary hydrogen economy, so generating hydrogen from renewables and then using that in both transport and the heating sector. This really allows you to simultaneously decarbonize the end use of energy outside of the electricity sector, but it also provides flexibility to the power sector to absorb those fluctuating renewables.
Thank you. So could you tell me more about the capabilities that the CSIR's Energy Centre has that could assist mines with energy decision support?
So given the significant capital investments that we are talking about for these plants, typically sometimes in the hundreds of millions of rands, it's really highly recommended that mines conduct detailed energy planning projects before moving into implementation. The costs of a non-optimized system will very quickly exceed the upfront costs of doing these kind of planning studies correctly. One of the core focus areas of the Energy Centre has been built out around this energy systems planning support, providing comments and information in terms of the National Integrated Resource Plan. And in recent times, what we've managed to do is leverage those capabilities to provide large industrial customers with their own sort of mini IRP. Many of the mines are naturally looking to on-site solar PV, and some of the analysis that we've done in the last year's project with the Mandela Mining Precinct was really, it showed that about 30% of the load can be met from on-site solar PV with effective financial returns. If you want to move to higher levels of self-supply, then you really want to look at a mix of different technologies that can meet your demand. And for that, you really need to do some kind of techno-economic optimization. Some of those technologies, for example, would include solar PV, solar thermal systems, wind, biomass, gas, as well as a very topical subject of energy storage. So what you would look to do is put that information into a model subject to certain constraints, and it will work out what the mix of energy should be, as well as when you should procure that energy. Many of these technologies are coming down a learning curve in terms of cost, and there's an optimal point of when to actually make that investment.
Thank you. So finally, could you please elaborate on some of the technological development that the CSIR's Energy Centre has that's also relevant to the mining industry?
CSIR really has a long history of technology development around lithium-ion batteries, and one of the key technologies that is used in many batteries around the world today was actually developed at the CSIR under the leadership of Dr. Michael Thackeray. We as a group maintain a strong battery materials focus. We have a research area that is specifically focused on cathode material development and really looking to how can you beneficiate local materials such as manganese. We are also working through the consortium Hydrogen South Africa. CSIR has done a lot of technology development around hydrogen storage, and we are also looking at power to liquid fuels and what those opportunities could be for the future. We've recently also launched a thermal systems laboratory in partnership with Sanedi that is really built around assisting industry with optimizing their thermal systems. That laboratory is really looking at waste heat recovery, power to heat sector coupling, solar thermal systems for industrial process heat, and really thermal storage as an enabling technology across the thermal value chain. Finally, we've also recently established a PV testing and quality reliability lab that is now operational and undergoing certification.
So Martin, what is the future outlook for this longevity of current mines program?
Fatheela, the program is now looking at demonstration projects whereby the Dingo is soon going to do the underground testing work. It also raised 2 challenge projects for the charging up of explosives, which is to be remotely charged, as well as the blast design, investigating new opportunities there to reduce the downtime, the re-entry period, as well as the charging up time. Secondly, the blueprints, we would like to extend that project, looking at the new technologies applied in the mining industry to capture those benefits and also to do the costing side of the process, so we can evaluate the scenarios, as well as then the shift cycles to capture those costing and come up with proper scenario planning and evaluation processes. From the optimization point of view, we've got the project supervisory assistance, which is introducing electronic capturing and reporting systems, as well as devices for the use of the miners and shift supervisors in the underground working place. Lastly, the project energy will focus on optimization of energy, utilizing the underground workings.
Thank you. So, from the wins of the longevity of current mines programs, it is evident that technological solutions may potentially increase safety and productivity, reduce costs, and ultimately extend the life of mines for the betterment of communities associated around mining and the country as a whole. The research work done by the mining cluster in collaboration with its partners show that it is critical to revitalize the mining research, development and innovation capability in our country so that South Africa can once again become the focal point for mining R&D. Finally, from an energy perspective, we see that mines can play a critical role in providing a customer response through embedded generation that can alleviate some of the challenges around Eskom's capacity constraints. I would like to conclude by thanking our panelists for their valuable insights and time, and I would now like to open the floor for questions.